Okay, we're live. So first presentation by Pavel, EC2 Cloud Computing.
I will try to cover it briefly. I will skip parts about AMI and EBS because I think Pavel will talk about it more. So what is EC2? EC2 stands for Elastic Cloud Computing, and that's basically cloud computer in the cloud. Or like other people say, it's someone else's computer. So it's one of the basic building blocks of AWS. It's the one of the first ones, or the first thing that they released, together with probably SNS or SQS. It's just a virtual machine that you can spin instantly. And talking about that, we have two types of it, or even three types. It can be paravirtual or hardware virtual. Right now, the current generation use the second one as default, so it's thought to be more efficient. So we spin up a VM from the prepared VM images called EMIs. We have there a lot of ready-to-use Linux distros, even FreeBSD or Windows Server. We can connect them via SSH, or to Windows Server we can use remote desktop. And I think Windows is extra paid because of licenses. In addition, there is it's called a VM marketplace, and people can upload their images. You can find ready-to-use WordPress or other stacks or other variation of Linux distros. So what can we choose inside one VM? We can tune not exactly the number of CPUs, but each VM is described by it. So we have vCPU, which is I would say it's a hyperthread. It's not exactly separate CPU. It might be a core or hyperthread. We have some kind of instances that can burst CPU usage, like you can have in T types, you have a byte-line performance, and for a short period of time you can get more.
How is this, like, how it's actually done in an OS system? Like, how you can change the number of cores on the fly in Linux?
I don't think it's number of cores, like performance of one core, but I'm not sure. It's like it's speed upgrade in your system. You can increase frequency, right? I think it might work similar.
Okay, so I'm starting with 20 cores, but they are actually run on like 10 physical cores, and in burst mode, it actually they're not run by 10, but they're.
I'm not sure, but I believe it's like 800 megahertz, and if you enter burst mode, it's 2 gigahertz.
Someone pushes turbo button.
Yeah.
There's a button.
A guy sitting next to
because it could be like airline schedulers, like you can have like 20 schedulers for 10 cores, right?
Yeah, but it's not like for such big instances, it's rather for smaller ones. Okay. Like this T2 micro small, it's like if you have not even spread of load, for example, website or something, that you don't expect to have a constant performance. You can choose these instances. They are a bit cheaper, yeah, but they not guarantee the CPU performance. And there is a limited time for this burst. There's some notion of credits. If you don't use the CPU as much, you earn credits, then you can spend on this burst automatically. So it's not like you can overload it 100% of time. Yeah. And there are metrics for these credits. You can query it, etc., etc. Of course, we can tune memory size and pick a high memory instance or low memory instance depending on our needs. And the other important factor is network performance. There are two kinds of description of it. There are low, moderate, and high, and I don't know what does it mean exactly. Like they don't guarantee anything. It's like you have a moderate network, that's it. Or you have guaranteed instances with 1 or 20 gigabits there. I think Pavel will talk about storage. Right now it's mostly EBS. It used to have instant storage, which was ephemeral, like it disappeared when instance stopped, but right now, as I can see, every instance starts with EBS by default. And we have a lot of, we can pick 8 CPUs and 128 gigabytes as we want, but we need to choose from the instances we have. We have several types of it. On the right, we can see sample configurations. So M is instance type, general purpose. 4 is a number, it's generation number, so it's 4th generation. You can see sometimes 2nd, 3rd, and then the size. And yeah, the general purpose are quite equal. Like you have many CPUs and much gigabytes of memory. But on the other hand, we have X, which is X memory optimized with a big amount of memory. And you can even see 1,000 gigabytes. So it's huge instance. I don't know if you want to go into details, but we have general purpose, compute optimized, memory optimized, some kind of storage optimized, I/O optimized.
What is dense storage?
I think it's for databases and such thing. I don't know how exactly it works, but it's optimized in a way to have many disks or something, or application that needs to store a lot of data.
I have a question regarding type. That you wrote that it's a better NW. What do you mean by NW?
Could you repeat?
Okay, so maybe in different way. What's the difference exactly between T-type and M-type, except costs?
Burst CPU, M general purpose doesn't have burst capability. That's the main difference, I believe.
Do you have more than T0 or like the small T's? Because micro instance,
it's micro, nano, small.
It's T. Anything above is, I think, M.
There's more of them.
Well, we can
okay. But yeah, it used to be only T micro, but they introduced nano, small, and I believe there is one larger. We can check it. And one interesting thing is FPGA, but it is, as far as I can see, it is not available at least on AOL account or any my account. I know everybody's seen it. I think it's like beta access only.
Yeah.
So if we became partner, probably we can have a preview.
Yeah.
I guess there were some perks. Yeah.
The HDL skills.
Yeah, RTB on.
Oh, actually, Sebastian is actually HDL.
So I suggest to go by yourself through this list, see what exactly are the differences. Oh, there are also one for media processing and GPU accelerated. And we have, I don't know if purchasing is the best word here, but we can have different approaches to buy those instances. For example, the classic and the first way is on demand. Like you pay by the hour. It's just you spin an instance. You can stop it every time you want. Just the default way as you imagine. You can reserve capacity, and then you have a discount. It's like up to 70-something% if you reserve it for 3 years. I don't know if you remember Wojtek's cost analysis. There is a big difference if you do it. Of course, the longer you could commit to use it, the bigger discount you get. And the problem with that was that it's not easy to migrate it between exits. But I found a blog post like today. It is like 1 month old. that they're adding more flexibility to it. So right now you can move it between AZs or switch OS and improve instance type and don't lose your discount. The other thing is dedicated host. You can have a physical server there. As a Cloud Guru guide explained that it is used for licensing. If you have, I don't know, maybe Oracle or something that has a license per one physical host. If you want to be compliant, you need to do that. I found that it can be reserved on demand too, like you don't have to commit for a dedicated host for a long time. Of course, it's for sure is much more expensive. Something less dedicated is dedicated instance. It's single tenant, so you are the only one who uses this physical host. That's how I understand it. So you can have many VMs on physical host, but all belongs to you. So no
noisy neighbors, right?
Oh, no, unless you are a noisy neighbor, but no unknown neighbors. I've seen scheduled instances, like you can spin them on recurring schedule, so every end of month or something. Spot one are interesting. It's like a marketplace for unused resources. You can pick a spot price, like let's say you bid $1 for instance when the price is okay. You bid $1, and if there is available capacity, they will give you that instance for as much time as price goes up. So if anybody else bids $100 with $2, they will preempt your machine. But the good thing is about it, like if your machine is preempted in the middle of an hour, you won't pay for that hour. So the next guy will pay. So if you have a long-running computation that can be preempted or something, you can back up your field spot instances. I think that's how it's used. So no time pressure to do some computation right now. Or maybe science guys can use it. But you have to be prepared that they can shut it down. As far as I know, there will be a notification, but you need to clean up quickly. You ready for that? When it comes to deploying it, so when we go to the wizard and click create new instance, we need to decide where to deploy it, like the subnetwork. So subnetwork, it's not exactly the same, but it's like which AZ it is. So because subnetwork can only span inside one AZ, it can be either public or private. If you use default VPC, all public subnetwork machines will be assigned with IP address accessible from internet. We need to add security group. I don't know if you talked or I watched about it, but it's like a IP tables of firewall, which is stateful. Stateful, it doesn't mean like somebody opens the connection on port 22. It's like incoming one. You will have outgoing ports enabled too. You don't have to configure inbound and outbound rules. So it's like established in IP tables. Good thing about security groups, they're updated on the fly. If you change something, it's available immediately. You don't need to restart the machine. And of course, these security group rules can be shared between many instances.
One thing about that, you need to remember that if you have EC2 with network interface specified, and you add a security group, then you will destroy the instance. This is something to be aware of. You can just add or remove security group from network interface when you want to have EC2 with public IP.
Okay.
And in the other way is private. You have two ways to add security groups to EC2 by assigning to network interface or just to EC2. And if you just do EC2, then you don't have public IP, but you can remove security groups. It will not replace EC2.
But once I have a security group, I can change it without problems, right? Once I have assigned, yeah, okay. Like rules inside security group. Keeper, we don't see that AOL, but when you create instance, it's required to have at least one SSH keeper to be uploaded there. And public IP, as I said, by default, in default VPC, it's added if it's public subnetwork. If you create your own VPC, I believe it's not enabled by default. So you have to explicitly say that you want a public IP. Extra features that every VM has, like boot scripts, you can put a piece of bash that will be executed after instance starts. We have user data. You can also attach some data to the instance, like put some values that will be accessible via this HTTP endpoint. And metadata works similar, but this is data provided by AWS. It can query for AMI ID or IP or hostname or something like that, some basic info about instances. You can do a snapshot of instance and then even bake AMI out of it. I think Pavel will cover it. Placement groups, that's an interesting feature. You can bundle your VMs together in a logical group if you want to have low latency network. For example, we want to create a Hadoop cluster or any other database installation. You want to ensure that they will have as low latency as possible, and placement groups are the tool for that. Of course, it is within one availability zone and not available for all instances types. I believe, for example, T types, it's not possible to have a placement group. So only for compute optimizing the instance that's supposed to be clustered. We have auto scaling groups based on metrics like CPU usage or any other things. You can change size of the group of hosts automatically. I think it's a separate topic. It's not to be talked about in 1 minute. And of course, it has good integration of URB, SNS. Like they can, EC2 can send events to SNS that it's boot up and it's terminating. If you want to monitor it, you can, by one click, I believe, hook it into CloudWatch. One important thing about CloudWatch, there is no memory metric for EC2. Like you can monitor CPU, IO throughput, network too, but no memory. Like it's not obvious. And there was a question in this sample exam about it, if I remember correctly. And we can also use CloudWatch for logging. Pricing, as we've seen, the basic component of the price is instance type, whether it's compute or memory optimized and how big is it. There is a separate pricing for storage, like each EBS you add cost. We pay for data out transfer mostly, and of course extra, or just for elastic APs assigned to instance. All in all, the whole pricing is complicated. One needs to study it. And I think that's it, yeah. Any questions or? It's becoming more obvious to go there and click everything.
Yeah, I see this is the kind of thing that you need to.
It's like
go deeper just by using it.
But in one sentence, it's just a VM that you can spin on demand.
Well, but in terms of exam, these
Mhm.
things like these CloudWatch and metrics, there's these little things. Doesn't think of me how much work to remember.
Yeah.
Okay, okay. Any other questions, comments? Last call. 5 minute break and we meet for EVS.
Yep.
Okay, okay. So let's start half to 11.
Okay, guys, let's get started. Second presentation, ELB, by Pavel Hajduk. Pavel, floor is yours.
Okay, let's start. Do you see my screen?
Yep.
Okay, cool. So I will be talking about Amazon EBS, like Pavel mentioned before, just volumes for EC2 instances. So what features EBS provide us? First of all, it's persistent block storage. So we just attach a volume to existing EC2 instance and we have space for our stuff. Good thing is that our volumes could be snapshot and stored in S3. And we are charged only for modified blocks. So for example, we have 50 gigabyte volume and we changed only 5. We are charged only for those 5 gigabytes stored in S3. Also, volumes are automatically replicated to increase availability. And it is important that they are replicated in the same zone. I found an information that in the exam, there is not so many questions about EBS because it's simple service, but there is a question related to this matter because there is only one sentence in documentation that it's only replicated in the same zone, and looks like guys decided to ask about that sentence. So remember it. Also, like Pavel mentioned, those volumes are not destroyed after EC2 instance is down, but we still pay for it. So we could assume that if we are not using that volume because EC2 is down, we are not charged for it. It's wrong. We are charged for it, and we will see later that how much. EBS volumes are also very flexible. We can modify capacity, performance, and even type of volume without detaching it from the instance. So it's pretty cool. We also have an option to enable encryption, but I won't dig into details with it. And also access management. As far I know, it's pretty similar to that access management from S3, which yesterday Piotrek said. And yeah, that's the main features of EBS. Maybe a little bit more about snapshots itself. They are versioned, so we can remove any snapshot, and previous one, for example, will be there still. Interesting fact that is we cannot access those snapshots through S3 API, only through EC2 API. So we won't see them in EC3 bucket, as far I got a chance to find out in documentation. And yeah, we can make snapshots in real time, so there is no need to unmount volume from running EC2 instance. Okay, so now we have two types of storage, SSD and HDD. The very popular is SSD. Correct me if I'm wrong, but it's default one, right, guys? If we create EC2 instance, yeah. The SSD type is a little bit more expensive, but I will tell about it a little bit later. The main difference is that SSD have low latency storage, and you can achieve more I/O operations per second through this type. HDD types volumes are mainly for high throughput stuff. So, for example, we would use it for big data like Hadoop or some storing data for business intelligence, and SDD for example, MongoDB or some SharePoint on some SAP services.
Question?
Yep.
So on both types, they are actually volumes that are not like existing on physical hardware that runs the VM, right? This is like all attached via network.
Yeah, exactly. It's not coupled with EC2 instances anyway.
And do you know, like, what is the chance that this SSD, this EBS volume is nearby, or like, does Amazon have like separate data centers for them, and or usually you have a rack and you have the hypervisors for like EC2 and then EBS, so that they're it's really close. I'm just wondering if you know any.
To be honest, I'm not sure about the correct answer, but later I will tell a little bit more that you can enable EC2 instance with flag which increase EBS improve EBS integration. So I think there are two cases. For example, if you enable that flag, you can achieve higher I/O operations per second. So I think on physical level in data center, it will be a difference where those EC2 instances and EBS volumes are stored. So I would say, answering for your questions, both.
Okay, thanks.
Okay. We have two types of SSD storage. First of all, is general purpose, and here pricing is pretty simple because you just you're charged by gigabyte per month. It's cheaper than the second one, and baseline performance is 3 I/O operations per second per gigabyte. And like you see, it's per gigabyte. So if you want to achieve higher I/O operations per second, you need to increase your volume. And later I will tell a little bit more about it because the second type, IO1, provides us better performance, but they are charged for it. So like here you are charged, like in GP2, you are charged by gigabyte per month plus per provisioned IOPS per month. So it's a little bit more expensive, but you have better performance. And maximum provisioned IOPS is 50 per gigabyte. So if you want to have more, you just need to increase the size of the volume.
I have a question, Paolo. What is an I/O operation here in this matrix?
It's just I/O operation per second, but it's...
What is this I/O operation?
For example, disk read, I would say. To be honest, I'm not sure 100%, but because I found information that this is some abstract AWS term about I/O operation. But for example, how to say it?
Because like I'm wondering, like from application perspective, I'm opening like a file descriptor, and then I'm doing a sequence of syscalls like read and write, right? But there's buffering. There is like the disk can buffer, in the hardware and all of this stuff.
I Google it, and IOPS are unit of measure representing input-output operation per second. The operation are measured in kilobits, and the underlying drive technology. determines the maximum amount of data that volume type counts as single I/O. So for SSD, it's 256 kilobits, and for magnetic is 1 megabit.
Okay, so this is like maximum what we can get with one write,
Yeah, or
without
read.
OS buffering.
Mhm.
Okay.
Yeah, but you're charged for started amount, right? If you use less than one such unit, then you're charged for use that one. So
Yeah,
it's okay.
Read disk in big chunks.
but there is there is when small I/O operations are physically continuous, EBS attempts to merge them into a single I/O up to the maximum size. That's the description.
Okay, so in this case, you will be charged less. Did I understood correctly?
Yeah, like if you have two small reads, it can be counted as one big I/O.
Because they are batching them and sending over the wire as a one packet, like the Nagel algorithm. But
Okay, but those operations need to be performed in some specific time, I would say, or it doesn't matter when you are doing it.
probably, yeah. But I think that you're actually like, we can forget about this optimization, but I think you're right, Pavel, that from what I'm hearing, it makes sense that you're charged for every attempt to read, to write.
Okay, so topic closed. Shall I proceed?
Yeah.
Okay. So the question is, we have that more expensive type, and we have those IOPS stuff. So would it be reasonable to, for example, provision bigger GP2 volume instead of IO2 and gather the same performance? And I checked it because I read it on one blog post, and one guy prepared pretty good calculation of it. And yeah, you can achieve the same performance with the cheaper volume, but you just need to provision bigger space for it. And it's cheaper than creating a more performant IO1 volume type. I pasted here a link, so if you're interested, you can read about it a little bit more. Because in higher volume, when you have bigger capacity of the volume, it's much cheaper to provision bigger GP2 than smaller IO1 with bigger performance. Okay, and HDD, I won't talk a lot about it because it's not used and it's not popular so much as far I know, but it's cheap. The pricing is the same. You're charged by gigabyte per month. And like I said before, it's good for infrequent data access. And also we have the second type of HDD storage. It's named cold HDD, and it's even more cheaper than the previous one, and it have poor performance comparing to the ST1. Okay, so like I said on the very beginning, we can launch EC2 instance as EBS optimized. So you can use full provisioned IOPS utilization and use, I would say, you can use then all performance the IO1 volume type gives you. But correct me if I'm wrong, it's not enabled by default because EBS optimized is charged, so it's not free. If you want to have EBS optimized EC2 instance, you need to pay for it.
What is the factor? Like how much? What is the difference in price?
To be honest, I don't know what's the difference in price, but I assume the difference is that you pay just per hour for it. So the EBS optimized EC2 instance is just more expensive, but I don't know exact value.
I'm just wondering like how they solved it. Is it like they're launched closer to DBS, or there's kind of like SLAs on like there's a quality of service ensured on the network to the EBS? Just wondering what you're paying for. But
I don't know, to be honest.
That's okay.
And of course, you can attach multiple EBS volumes into one EC2, but not otherwise. So one EBS volume can be attached only to one EC2 instance. So to recap, SSD IO1 is the most expensive one, but gives you good performance. Then you have SSD GP2. I'm not sure which one is default, but I would say the GP2 is default if you set up new EC2 instance.
I think.
Yeah. And later you have those two HDD volume types. And on exam, there is, I didn't dig into much into details about it because I didn't wanted to check all Amazon certification questions, but the EBS service is so, I would say, simple that there is, the questions are pretty tricky because, for example, that question related to availability zone, like I said, it's one sentence in documentation, so it's ugly trick to ask for it. And the second stuff which sometimes you can find on exam is that about snapshot scheduling, how to set up snapshot scheduling in AWS. So I don't want to put into details here about it because I'm totally not an expert in this matter, but I also provided a link about this in the web. So I think that's it from my side about EBS.
One extra comment, like if you use EBS as a root volume or boot volume where the operating system sits, by default it's destroyed with instance. When you delete instance, the EBS with OS will be also destroyed. The extra EBSs won't be, but it's boot volume, unless you tick the checkbox to not delete it. So that's the default behavior. So to destroy also root volume.
But if you enable that flag, it will just create EBS volume and it will persist, right?
Yeah, you can disable this behavior.
Okay.
But by default, it goes down with EC2, the root volume. Okay. But any extra will stay.
That's awesome.
I have one more thing. There's another type of devolume, but it's from the previous generation. It's
magnetic, right?
Yeah, magnetic one. I don't know if it's possible to create EC2 instance with this magnetic volume, but still you can create RDS instance with magnetic volume. So maybe it's good to know that it's still possible, and it's for infrequent data access mostly, and you pay here for a gigabyte per month as usually, but additionally you pay per 1 million IO requests.
Okay.
There's a price tag for it. It's like.
But isn't it like cheaper than normal? But you pay for rights.
Yeah, but you pay
for it.
Yeah, you pay for it. So it's like you don't. It's not the IOPS as. Oh, so it's possible.
There is not magnetic in the combo box.
So it's not like provisioned IOPS, it's like you pay for the reads you do and for the writes you do. to
So
the
this is
storage.
like a tape storage. Is that
I
so?
believe that it's kind of something like that.
Okay.
Sure.
But
But
No, it's
I think it's ADD.
yeah,
so that's what they mean.
slow
by magnetic.
HDD, right?
Yeah.
so why do you call it magnetic?
How the HDD works.
Well, like I know it's magnetic, but like why, normal HDD, or SC or whatever. Maybe it's on
They have
tapes.
like some older generations of hardware. They phase it out, or the interconnect is different. So the way they connect hardware to the network.
Nah, probably. I was just curious, if they have magical new type of disks that they're using for this.
Magnetic transfer.
I wonder what is the failure rate for EBS. They must have like piles of failed drives. That's interesting.
Okay, any other comments? Questions, guys, about stories of using EBS?
Maybe I remember one thing about snapshots. On Cloud Google, I don't know if anybody watched this. There was something like in Windows, the behavior is a bit different. Or maybe I'm wrong, like you have to unmount volume from Windows Live. But I'm not sure. If you do a snapshot on Windows,
Okay.
it's not like on the fly.
How do they do it that you can snapshot thing on the fly? Because they're not freezing machine, right?
This is what Solaris had in ZFS. They also have live snapshots. So they have this metadata area, which you can just, like copy. And
That's awesome. But if we don't have details, then that's cool. We can check it later.
A lot of bells and whistles. Actually.
I'm just trying to probe if anybody has more insight into this technology. But okay, no comments. Like, type something.
We can make AMI out of EBS snapshot.
We can make an AMI of EBS snapshot.
Out of like use it to produce AMI.
Okay,
But
that's
it's
interesting.
kind of similar, like snapshot works in a similar way as AMI. Like you can recreate EBS from snapshot with an operating system and attach it to running instances. You have almost the same as AMI.
Okay. Yeah, I guess
It's like a
that's
backup.
simplified. Wait,
But you can take a snapshot and create AMI. Okay.
this is how people were, a long time ago, I was reading how people were making like custom distributions on AWS, because like if you use AMI, like usually you just take some base AMI and you build on top of it. But if you want to build your custom distribution, you build your custom kernel, bootloader or whatever, then you do it like this. Just
that's good.
on TPS, put everything there.
That's awesome. Alrighty. If nobody has anything else, thank you guys. And see you later. Actually, when do you want to have the next session? We have Easter holidays approaching, so Monday is off. Tuesday, again, Tuesday and Wednesday, like this week. Sounds okay with everybody? 10 a.m. Tuesday, Wednesday.
Maybe a bit later, not 10, because on Tuesday everybody will get into the office.
Okay, 11.
Yeah, 11 sounds good.
Everybody.
Sounds good.
Okay. And we have, so we had RDS. Actually, we had everybody except Michał. Do we have any other volunteers for any other topics? We need at least one presentation for the next week.
Figure stuff.
I can talk a bit about API gateway and Lambda if it's like, but I don't know if it's like the main topic for exam or something.
Well, we need to cover these things anyways to know what we're talking about. We can next AWS plan.
So I can talk a bit about it.
So,
Here, which one?
API gateway and Lambda.
so
The next one, and I can connect it with static website hosting.
You can host static websites on S3.
Yeah, I know.
Over.
okay, so this will be
One sentence.